Hello, Doctor. My name is Miranda Khairunisa and I'm from Group 13. So, these are my group members. So, to start off, when an object rotates about an axis, each point in the object follows a circular arc, meaning that the points along this object all move through the same angle delta theta and a time delta t. Therefore, the circular arc has a rotation angle delta theta equals to the ratio of the arc length delta s over the radius of curvature r. Angular velocity is the measure of how fast an object is rotating. It is defined as the rate of change of an angle, represented by omega, where delta theta takes place in a time delta t, with the units radians per second. Usually, the angular velocity omega is proportional to the linear velocity v, such that v equals to omega r. Angular acceleration, alpha, is defined as the rate of change of angular velocity. In equation form, it is expressed as follows, where delta omega is the change in angular velocity and delta t is the change in time, with the unit radians per second squared. There is two different components, which are tangential acceleration and centripetal acceleration, as shown in the figure. In a 3D motion, however, angular velocity and angular acceleration have three different components, in the x-axis, y-axis, and z-axis, which will take form such as this in the figure. For our experiment, we are required to calculate the angular velocity and acceleration of a table fan blade, which is moving in a 3D circular motion. So the experiment and calculations procedure will be presented by my other group mates. Thank you.
Hi, my name is Ramil Saini and I'm going to explain about the design and experiment to estimate the firstly speed of the fan blade and secondly the swivel of the fan. And I'm going to explain how we conduct the experiment for the lowest and the highest speed setting, and also how we calculate the velocity and acceleration for the tip of the blade for both speed setting. So firstly, to analyze it, we measure the fan blade, which is 11 cm, and then the materials we use to do this experiment is sticky note and Kinovia software. So the procedure, basically we just open the cover, we put the sticky note, and then we analyze it using Kinovia after we recorded the rotation of the fan blade. So how to calculate RPM? Basically, when you open Kinovia, you can set a marking, a red point, and then for each one rotation, it is considered as 1 RPM. So this is the result for the speed of fan blade for different time, which is 30 seconds, 60 seconds, and also 90 seconds. The swivel is an action from center of the motor to the left and to the right. So in order to calculate this part, we need to know the radius of the swivel, which is 0.135 meter or 13.5 centimeter. For the swivel part, after we done our experiment, we found out that one swivel of our fan is equal to 27.58 seconds. And as for the speed, after we calculate it, it is equal to 0.06 meter per second. Thank you.
Hi Doctor, my name is Priya Tanrishini Murugan. So my part is conduct the experiment for the lowest and highest speed setting. Here shows the speed of the fan blade rotating about its axis at lowest speed. Here shows the fan rotating at the highest speed. This is the result that we obtained from the experiment we done for the lower speed. So for lower speed, we have divided three different timing, which is 30 seconds, 60 seconds, and 90 seconds to obtain the RPM of the fan. So to get the perfect value for each time frame, so for the 30 second, we have done 3 trials and then divided to get the average. In this table that shown that 30 second we obtain average of 789 number of turns. For 60 second we obtain 968 number of turns. For 90 second, this is the result that we obtain for number of turns for higher speed with different time taken. For 30 second, the average number of turn is 986. For the 60 second, it is 1170 number of turn as average. for 90 seconds is 1359 as average number of turn. So below shown the RPM that we get it from the highest speed. The purpose of this experiment is to calculate the speed of the fan. For the lowest setting, we need to know the fan radius, which is 0.11 meter. Secondly is revolution per minute, which is 968 RPM. The speed of the fan equal to 968 multiplied with 2 pi divide 60 second times with 0.11 meter. The speed is 11.15 meter per second. The speed of the highest setting is RPM for this setting is 1170, and then to obtain the speed we need to multiply 1170 with 2 pi divide 60 times with 0.11 meter equal to 13.48 meter per second. Here shows the speed of the swivel of the fan for lower speed. For the lower speed, one swivel equal to 28.24 seconds. To obtain the speed 0.135 meter, divide 60 times with the 28.24 second equal to 0.061 meter per second. Next is for the higher speed. For the higher speed, the time taken for the one swivel is quite fast, which is 14.02 seconds. To obtain the speed, need to multiply the 0.135 divide 60 times with 14.02 seconds equal to 0.
Hello, my name is Agusta. So now I'm going to present the velocity and acceleration of the fan at its lowest speed. So first we need to convert the speed to the radian per second. So this is the formula that we're going to use. So the head fan that we're using are tilting at a 45 degree. For the angular velocity, we're going to calculate it in the ijk vector component. First, we need to calculate it separately for Wx, Ws, and Wz. And then after that, we're going to total it up. And this is what we got from the angular velocity of the T-plate. For the angular acceleration, it also has its own formula. So, this angular acceleration for Z is equal to 0 as the fan is always consistently facing upward and does not rotate at Z. That is why it is equal to 0. After that, we calculate the angular acceleration at S of the fan blade and X of the swivel. Next, we're going to total it up, and this is the angular acceleration of the tip of the blade. Thank you.
Hi, my name is Abdul Hakim. Okay, today I will show you the calculation to find this angular velocity and angular acceleration for the higher speed. So first of all, we will find the speed for the blade, which is for the fan blade and the swivel. And then to find the angular velocity, we will divide it the angular velocity to Wx, Ws, and Wz components. So after that, after we find the value of the three components, we will get the angular velocity of the tip of the blade, which is for the highest speed of the blade, which is W equal to 2I plus 86.652J plus 86.889 K radian per second. So to find the angular acceleration, we will divide it the component into three also, which is Wz, Ws, and Wx. But the Wz is in constant motion, so it is Wz equal to 0. So the final value for the angular acceleration of the tip of the blade are as below: negative 20.537I minus 173.304J plus 173.304K radian per second power of 2. So that's all from me. Thank you.